Hi there. So today I thought I'd come back with quite a quick video about converting decimals to fractions. So we're going to be looking at terminating and recurring decimals and then a trick that one of my old maths teachers taught me. So I'm going to start with a terminating decimal, say for example 0.625. Now the first thing we need to do here is to put it over a suitable power of 10. Such that every single digit will be positive. So in order to make 0.625 positive, or in other words 625, we need to multiply it by 1,000. So we can see there will be 3 skips of the decimal place. So I'm going to put the 625 over this 1,000, which we can then simplify down. So I'll get 25 over 40, which can also be simplified even further actually, to 5 over 8. And we can go back and check this, because if we know that 1/8 is 0.125, 5 times 0.125 is 0.625. Now next I'll show you an example of a recurring decimal. So for example 0.2 and 38 recurring. So the first thing we're going to do here is make this original decimal equal to x, but in order to get nice numbers to work with, we need to be able to get rid of the recurring and just get an integer. So I'm going to do this by working with different values of x. So I'll say, for example, 10x would be 2.38 recurring. We know that 100x would be 23.83 recurring. And we know that 1000x would be 238.38 recurring. Now I'm going to look for the two with the same numbers after the decimal point, so I can use 10x and 1000x. Now what I'm going to do next is to take 10x, or in other words 2.38 recurring, away from this here. So I'll do 1000x minus 10x equals 990x, and 238.38 recurring minus 2.38 recurring is 236. And since we know that 990x equals 236, we can isolate for x by dividing both sides by 990 and get 236 over 990. And whilst not quite as nice a number as 5 over 8, we can still simplify this down to 119 over 495. So lastly I'll show the maths trick, which also happens to be another example of a recurring decimal. And this will be to prove how 0.49 recurring is equal to 0.5. I'm going to extend the number of 9s to equal x. So for my 10x I'll get 4.999, and for my 100x I'll get 49.999. And because these two, the 100x and the 10x, both have the same number after the decimal, I'm going to choose these two. So just like last time, I'm going to do 100x minus 10x to get 90x, and then 49.999 minus 4.999 to get 45. So if we know that 90x equals 45, we can isolate for x again to get 45 over 90, which is exactly a half, or the 0.5 that we had at the beginning. That's it, folks. Thanks for watching.